Hang on. Maybe I'll put another computer. All right. So we've got 3 presentations tonight. Jerry and Sadiq and I are gonna present some stuff. Mine involves lasers, obviously the best. So I'll go last. Sadiq, do you want to go first? It won't be too painful, I promise. Maybe. So you gotta hit got it on there, and then if you want to share your screen, I'll do it. All right, take it away.
Hi everyone. My name is Sadiq, and today I don't really have much to present, but just something fun. I like playing around with art online, and most of the things I find fascinating is like generative artwork or creative programming. So that it's like a nice brain testing thing where you can just challenge yourself. Hey, can you create something that generates this in a short amount of time, whatever. And I was messing around with a few things last time. I was actually messing around with anyone who does creative programming. Yes. Have you watched any videos of coding training? Yes. Yeah. So I love the YouTube channel coding training. I could spend all my time there, and I kind of stole this idea over here from that. From coding train, and I tried implementing my own based on what I watched, and I kind of get it good close to that. And the idea here is to like create a flow field of like particles, and let the particles like move based on the flow field that you have, and just to like actually give you an idea of what I'm saying.
Did you write all this code, or did you find examples in places?
The examples are on the YouTube. Okay. So the example for this one over here, it's on YouTube. Then you can look at it and look. Yeah. Oh, yeah. It's not like hard anything. So it's like it generates some cool video.
Does it generate different patterns every time?
Yeah. Well, it does generate a different flow for like formations each time you All right, so something like this. So this is like guiding. This is what it's actually following. The particles are following this kind of thing. And I was interested in it, so I decided to like come up with my own thing that I can create, and I came up with something. Won't look really good on here, but something like this. And the idea is to have like a magnetic kind of particle moving around, and all the other smaller particles following that particle to like generate some weird, I don't know. Right now it doesn't, like, you don't see the real effect because I have everything blown up for everyone to see. But on this really like high resolution really to me. And I can try playing it in different scenarios. Let's try.
What's your noise function space?
For the Either one. So for this one, I'm not really using any noise. Like for the other one, yes. For this one, no. This one, I'm just like have like a particle moving around, and based on that particle, all the other particles react to that particle. Like, hey, this particle is close to me, or it's next to me, so I can follow the particle. And if the particle goes out of range, then it snaps back to its original position. It's not like a very complex. It's not like a very complex thing, but it kind of generates. It's right now it doesn't look really great on it looks really good over here.
Is the speed controlled?
Yeah.
Or is that because your frame rate is good?
So the frame rate on the drop because I have something but I had to like make it a little bigger,
Yeah.
so that people can see it. But this is what you get, but so you get some cool animations and everything. It's not really interesting. To me, it's great because it's some art kind of thing, so it gets me excited.
You okay?
And I also created some kind of sound. So the main idea here is for me to like create such videos, like tiny videos, and try. I started getting into like producing sounds or songs, and I want to like create a song that fits the video as a challenge. And I came up with some other.
Who wants to know what platform or language you're using? It's processing, right?
Yes, I'm using processing, and it's using Java as well. Hopefully it doesn't. Of course, it's something that something great. That's the sounds are better in the headphone, but anyway, it's a kind of relaxing sound. It's trying to follow that. It is like the lowest, like the lowest, the highest in the phone with tiny particles. It's not a really good effect. On is this, that's good. It's not good. It's terrible. Excuse me.
Did you correlate the music to the YouTube, or is it just something that's similar?
I tried correlating it with the movement, but it's not. Doesn't sound great. So I had to like just like look at the video and try to like imagine what kind of sound it could make, and like, yeah, that's what I came up with.
So the sound was not generated by the same algorithm that generated the.
No,
okay.
no.
It looked very close. I thought
Yeah.
you would find.
Yeah, that's the challenge for me is that you generate videos just like this, and then like try to like imagine a sound that follows with the video. Oh, yeah. Any questions?
So I missed your your presentation last month, but I'm just wondering if you're going to tie this into the robot, maybe get the robot to like kind of dance in the wind with it or something.
Actually, I do have an idea of making the robot dance. Yeah, I'm actually that's one of my like, challenges that I have is to like it's going to be a little bit challenging because I was imagining something like this, but I don't see that happening with that arm. Like the arm, I guess I could make it like do some like kind of waving kind of thing, but
You should hide the robot and put like two legs.
Oh,
It's like white, so it's like white.
I was thinking if you could get one of Bob Badley's, like the wacky wavy.
Oh,
things.
there you go.
yeah, I have that idea, and I kind of also thought of like making it move based on sound, but then I was like, I could maybe make it like full of commands, like hey, move left or right, something like that. But giving it a wave function or something, I don't know, it would act weird. And
Just tell me you need 2 robots.
yeah, I don't know. I'm dealing with one is already hard. It's already had enough to deal with one arm, so it's good. Yeah. So that's all I have for you guys.
Any other questions for Steve? Thanks, Steve. Hopefully the thing works. Jerry's gonna print one of these for everybody who came tonight. So.
Hey, man. All right, give me 1 second to set up.
We can grab all the presentations that have been done here. How far out with 3D printing stands compared to all the other?
I don't know how that we've had a lot of 3D printing presentations. There's been like a fair number over the years. I'd say like fan conversion projects or I fix shit in my house projects would be probably the standout favorite. Splitting boulders in half, that'd be a small one.
And thank you for the presentation. I just want to come here and split another one.
Absolutely. You make it half round boulders though.
That's it. We just got to bring bigger and bigger boulders in.
Well, smaller would be perfect. Just splitting the same.
That's
You get
what
it.
again. Just put 1/2 quarter.
You. Yep, you're good. Take it away.
All right, so hello everyone. I'm Jerry. You probably see me sitting over here playing games. When I'm not playing games, I actually work for a company called Cozy, Collaborative Science Environment. What we do is that we use our 3D printers here to build scientific instruments that our researchers use in their labs. Which means we actually do a huge ton of 3D printing. Like we go through, I don't know, 20 kilograms of PLA in a month or two. So it's rough. And we are currently using a bunch of CR pins. They're reliable, but they're super slow. They go about 15 mils per second, which is pretty standard for the bed slinger style printers. But some of our prints would last like days. And that brings quite a few risk factors. Some might happen during that time, like there might be some layer skipping, or Chris messes up and sector loses power.
I would never do that.
Yeah, so speeding up the print is pretty essential. You can do that in 2 ways. In the slicer by just for speed, but that might just shake your printer apart. That's not good. You can also decrease your refill, but that would also lose strings. So the optimal way of doing it is to speed up your print. However, due to the design of these printers, there is only so fast you can go before you're basically spaghetti all over the place. That's why a company called Bambu Lab, probably a couple months ago, they started a Kickstarter campaign, and they came out with their own printer. So they didn't come up with everything here. This is a 4xY style printer. It's been around for quite a while, but they managed to get quite a bit of the features. And put everything into a very smart system. So here's what it looks like. It's called an X1. And on the bottom, you have the printer, and on top, you have an AMS. AMS stands for Automatic Material System. So the idea is that you can actually change out the filament when we're printing. That way, you can do multi-color prints or even multi-material prints. Of course, there's some limitations, right? It has to be good at eating the materials out. But for multi-color prints, as long as you're using the same material, you can actually use some more material in one part. So that's one of their selling features. The other feature is that this stuff goes super fast. You can do about, like in the advertisement, they're saying that you can do 500 millimeters per second. So that's 10 times the speed of light for other computers. That's pretty impressive, but in order to reach that speed, you need enough acceleration. So they have 20 meters per second square acceleration, pretty high. But if your part is so tiny and there's not that much length to accelerate, it won't be able to reach that speed. But still, it's about 2 times faster. So let's see kind of other features that we have. Yeah, so this is one of the parts that we are really trying to highlight the AMS. So you can see we have 4 slots for schools, and we have a motor on each of the little schools, and then it can actually furl and unfurl each school, so we can put different material to the print head. You can actually daisy chain 4 of these together, either one printing, so we can get 16 colors. That's pretty extreme, and one of these costs about $350. So from that, it will be kind of fall off quite a bit. So a couple more different features. So here's a look at their column. They're using some proprietary hardware. It's not great, but they're actually selling it for really reasonable prices. But you can only buy them from them for now. No Amazon stuff. That's the game. So one of the reasons that it can print this fast is that they have a AUM accelerated fan on site that goes kind of a weird job part. So even if they're super fast, the material gets enough time. Now, that's also one of the limiting factors for other printers out there. There are different kinds of nozzles that you use. You can have carbon steel or stainless steel. And of course, a hotbed that is pretty standard for other printers. So one of the major features they are advertising is that they actually have a LiDAR and next to the printer. So basically, what they can do is that they lay down a layer, and through a layer, do a scan with the LiDAR to make sure the errors are still in place. They can also do all sorts of advanced calibrations with the LiDAR. This is somewhat of a gimmick, I suppose, because currently I don't have that, and my friends don't. But hopefully, probably does something for them. Pretty fancy. And with all these fancy features, they are selling their X1 model for about, I think it's about $1,300. So including the AMS system. That's actually not bad, right? That's a good price. That's a fancy printer. So they launched their program on Kickstarter, and I actually backed their campaign. But after a while, I thought about it. I might not need it. This might not work, right? So I don't ship. It cancels my pledge. So that's why I couldn't get my hands on one of these printers. Which is kind of lucky for me, because after about a couple of months, after 2 months after they delivered all their Kickstarter printers, they came up with a second printer. It's called a Bambu P1P. Just on the picture, it's a stripped down version of the Sadiq port. It's basically using the same manufacturing labs, basically using the same robot that knows the frame, and then it took out the LiDAR. They also took out the frame. So it's a very durable machine. But it contains like the speed and the color changing ability to get the AMS system. So this printer is a lot cheaper. You can add your own design for the size, or you can do like me and like this. So it advertises fast setup, multi-colors, and very fast prints. But of course, since it's using the same hardware mostly as your main printer, has the same speed and the same accelerations.
Hit play on that video up a little higher. That's one at the top.
Here?
Yeah. The thing is like insanely fast, like really insanely fast.
That has like sports mode.
So, Jared, can you explain how you said that one of the reasons they can go faster is to figure out who without the layers? That's one of the limiting factors.
Yeah, so for example, these standard printers, they have one cooling fan that cools the hot end, right? So that there's no factor of heating, and another part side, right? That's right. this also has the part, but on the side it has another huge floor fan that goes higher build plate. And since the build plate moves down, right? And the surface that just got laid down to the part always stays on top, so we're always this current layer.
So they all they deserve.
Really big fan. It is.
And the premise is because if you print that fast without living, then you're just gonna get a blob of
You
plastic.
get blobs, yeah.
So there's no air conditioning. So it's still just.
Yeah. So is your thing. So this picture, they're selling it for $6.99, which is a lot cheaper and a lot more useful. So I said, hey, why not, right? I bought two. So it's about the same price as a regular X1, but I got two printers, and I'm not moving out that much. So no weird LiDAR system. They're not worth it, but that's why
You'd rather pass on your birds. Your parts.
yeah. So yeah. So that's sort of a big under. How much time?
How much time you need?
Right. So I also got a material changing system, floral system. So it allows me to change colors for a print that I'm doing. So to test out that feature, I found a pretty good logo, NASA logo. Right? It has a very limited amount of colors, 3 colors, like blue, white, and red. And it's also free available online for the vector files, so to message it that much. And new print. So these actually with they use
How long did it take to print those?
5 hours.
5 hours?
Yeah, 5 hours. So at each material change, it does a printing motion. So
Yeah, that's
okay, yeah. Because it's gotta clean out the print, right?
But then slow down. Why would they you print it in one color?
oh, probably like 1 hour and a half.
Yeah, so it triples or quadruples. Is that all because it hasn't changed color?
Yeah, so it has to scroll back the millimeter, pull it out, and then get a good millimeter, and then turn it out. So it's a pretty time-consuming process, but it's also pretty clean if you actually do this.
If this is $600 or $700, you got, that was with the AMS or without?
Without AMS.
About 1,000. So each one of those is only $500 if you wants to buy one tonight. Maybe.
And does it do the color proof in a very specific spot or just kind of around like a turbo?
So on the back of the printer, there's a shoe.
Oh, okay.
The printer moves.
Boop shoot?
The loops.
Okay.
And I actually, so this is the toilet. It's on the back, and here's where hey, to have my time where. All right, cool. I'm gonna quickly talk about how simple, how difficult it is. Yeah. Okay.
How much does that increase the amount of dough they consume? Like you know how many grams this is and how many grams actually get used next to it?
Yeah, so on the slicer, they do have a feature that tells you how much printing is going on and how much printing is going on. It totally depends on where your color changes are, and how many changes are changing, and also how much colors are changing. If we're changing to blue and red, there's not that much purging either. You're changing to white and black, right? You push quite a bit to get all the black out.
How much fiber eats?
How much fiber it eats.
Oh,
So do you have like an example for that, the NASA one that you printed or anything? Or?
I think that's what he's going to show you on the slide.
yeah.
Right?
All right, cool. So I'm going to quickly go through how to design a part that is optimized for multi-color printing and how to slice it and set the colors. And so this will demonstrate that this is not a really difficult process, but essentially, they're going to take some things like this. Okay. Let's do this.
And the NASA logo that you started with was all one object?
Regular STL. Yeah.
Yeah, okay.
And you end up painting it
Oh.
in the software that's going to show you.
That's
So they're using it as blank.
Hey,
There you go.
hey. All right, so right now I'm remoting to my desktop right here. Not great, but it's all right doing it. So to get started, you need a face file basically. So this is a vector file of the NASA logo, and I got it off of Wikipedia. And you can of course do other kinds of logos, like Sector67, any kind of logo, even if it's a photo, you can still image trace it in Illustrator to turn it into a vector file. But right now we're starting with vector file. Usually this is fine. You can export this into a DXF or a DWG file that can be recognized by CAD programs. So I have already done that. So I'm just showing you what the original file looks like. And next, we go into our SolidWorks for that. Go into this. So here's the first step, right? You load in the NASA vector you had here, and that extrudes a face, the round face for areas you specify. And after you extrude the face, you extrude the little tiny white star. And one thing to make sure is that all these stars have to be individual parts. They cannot be combined into the face, right? So the goal here is not actually to export a XCL package. The goal is to export a 3MF. Right. So for some reasons in SolidWorks, we're exporting STL in a part. You're actually combining areas, right? Instead of each individual function. Although it's also possible to paint the STL file. It takes so much time and so much preparation to just solve the part. So it's much easier to just have individual solids inside your design. So these are the tiny white stars. They are now individual solids. I think I have 40 solids right now, 40 base parts. And the next step, we do a little white ring around the side. So although this is only one extrusion, also it's 3 parts. So it adds a couple more parts to our part count. Then we do the next part. The little arrows on the sides. So individual parts. And then the top half arrows. So you might notice that even though these two are supposed to be all red, the same color, there's still 2 parts. So what we can do is that we can actually combine the same colors so that there are fewer parts when we're setting colors. It makes this very a lot simpler. So the next step, you get the NASA date and the NASA letters up here. And, after that, we combine the separate solids that have the same colors. So combining one, probably adhesive. Let's combine. So use the top here. So these combine basically combines the same colors, so it reduces the amount of solids we have. Finally, the chopper starts. So this is a very quick rundown of the process of changing a photo or a vector file into a solid. Yeah.
Does it save any print time by combining those solids?
It doesn't change save any print time, but it saves the time of you manipulating all of these inside the slicer. So you're not in the slicer yet, we're still designing the part that we're going to print. Okay, so this is going to be the part that gets printed. Currently we have 59 solids in here. So we can actually set each individual solid to different colors. So we can have, maybe not 59 colors, but have any colors, but multiple colors for each individual part. So in here we can then export. And export. Actually, probably say that. So save as. You have options like FTL and that's 3MF. So like I said before, SCL combines your 59 parts into one solid, and you'll have to paint everything again. But for 3MF, it actually keeps the arrangement and the individual solids. So that might be the future. All right, so after that done, we open up the Bambu slicer. So this program is called Bambu Studio. It's based on Super Slicer and Pre-Chef Slicer. So since those are all open source, it's also open source, and they did some pretty interesting things. for certain iteration. So in the middle of the build page, you can see the model we just made, right? It's the same NASA logo, and we have all the stars and everything else. Right now, all of these, right, and this part, it's gonna work. You're just going to get it part of the single color. You can take a look at our device, and on the right, we have a control panel, and on the bottom here, that shows you what material you have currently for EMS. So on the proprietary film they're selling online, their schools actually have a little NFC. So if you load it in, the AMS automatically recognizes what kind of filming you have, and also goes in the settings for that thing. They're not that expensive, but I'm still keeping that. So I buy all my films from AliExpress. You get to set whatever color you're putting in. So make sure that we're using the colors you have inside your AMS color. Otherwise, it's not going to recognize. So we go back to our menu. And in the settings right here, we have a global settings, that's just the normal sizes. And on the right here, we have the objects. Here's interesting, right? So all of these items are the solids we made SolidWorks. And we can select them to have different colors. For example, right now I'm selecting the base. You see that we have clear first. Right now today, so now the printer knows that when it's printing this part, use the blue filament inside the MS. Now let's take a better look at what the application looks like. So we can see that we have a blue base and a red, let's say it's an arrow or something, and everything else is white. In our slicer, the default color is already white. So all we need to do is find the red parts, set it to red, and we're good to go basically. So we can go through all of these parts, and you can see each individual thing highlighted. Right now it's all the same stars, that's why it's not good. Oops. Actually, I'm doing this. Okay, so now it's highlighting all the individual stars. So we move to the part that we want to change.
Can you not click on that the part?
Nope, that's one feature that I would
Probably got it back.
Right, so now again, we're actually on one of the red parts. So set the red part, element part, element. All right, so that part has been set to red. Same thing to the next one.
Why are all the parts maybe?
So what?
Why are all the parts made equal?
It's a subset of the file name, because that's the meatball logo.
Oh yeah, so the
Oh, that's what it's called. It's
so
called
NASA
meatball.
has two logos. One is this, it's called meatball, another one is the red NASA, right?
Yeah.
But that's called the worms.
Called what?
It's the worm, the snaky, this is logo, it's all one line. This is the meatball.
I thought meatballs is from some remnant. That's just part of the 3D.
Jerry was hungry, so.
And then Archie Bunker
His alpha was, no, you were right. It had it.
Oh, that was. Close.
I'm the one that was, I think you had it right there.
Hey, get your right here.
There you go. So you can export individual STLs, you can tell SolidWorks not to combine them, but this works fine.
Oh,
yeah, that was good.
yes. So yeah, inside the site, we now have a basic illustration of what would come out of the printer, hopefully. And we go to the preview section, go to site address.
What's the French flag up at the top there?
That's the first tower.
Yeah, okay.
That's the other half of the wrapper.
That's what I thought.
Actually, it prints junk on the front and on the back.
So the first tower is a remnant of a past state where you don't have ship buckets like this. So we don't actually need the first tower to disable it. But here's the interesting part. Here, that's where it's tells you which color you're using and how much of it. So, for example, white, they're using 11.3 grams of white, they're flushing 9.52 grams. Wow. Yeah, blue, that's a little better, they're using 100 and 14.87 grams, and it's talking about 2 grams. So basically, even if you make this into a tiny mix, it's still flushing out of material now.
Because every layer's got an overswitch.
Yeah, so it's most efficient if you can make multiple same design. So much more of the dose. This is efficient.
So you need a bigger printer, that's what you're saying.
Yep, a huge one. So yeah, that's basically a simple rundown of how this works.
Now, back to your speed thing, if you were to print this on one of your old printers, and let's just say all one color, in both printers, do you think it'd go 3 to 5 times as fast?
So I think on a regular printer, that would be about 8 hours, 9 hours, that's a fair estimate. However, that doesn't include the color sheet.
Yeah, right.
And if they're not doing color sheet, it's on this, done in about 3 hours.
Okay.
Then the current estimate for this is 5 hours and 50 minutes, so that's 6 hours. Pretty fast, considering the color.
Does it say how many times it's changing color?
Yeah, so permanent change time 72 times.
Okay.
You play with the heights to make that more efficient.
So it prints 2 layers of each color. Well, it prints 2 layers, yeah, because the nozzle comes to be dodgeable 2 layers.
Yeah, and you can be more efficient in designing the part, right? Because the color changing, you basically only want colors on top, right? If you make the color changes shorter, you're doing less layers that have color change. But that would also save.
And this, most of that 72 times is probably the red and the blue, they're all on the same level.
Yeah.
Because once it gets, well, then the white and the red are all on the same level too.
So I also printed a couple of snowmen. I'm not sure anybody saw them, but yeah, those couple of snowmen I printed actually had way more print material piece as well as the design of the snowman. It required much more color changing and so you have to keep that in mind in designing for color changing prints. How much material actually waste. So that's another design consideration I got on designing for
This is the snowballs.
Yeah.
What layer height are you?
But these are 0.2, this is a 0.4 knot standard. And although these are proprietary nozzles, they sell setups on their website. And so these are actually not nozzles. The nozzle and the hot end are combined into one. I think somehow they maybe somehow make them. So you can actually change out nozzle, change out the entire thing.
Does this have the 3
No.
coming? Okay, so I know some of the hot ends are bringing it up higher to have more heat in.
So in the future, they might come up with higher flow nozzles that allows you to actually more. Currently, that's what it is.
One of the print speed limitations is the ability to drive heat into plastic. So we're approaching the point where the plastic is so fully conductive that you can't get heat into it quick enough without burning it.
Oh, so then you're like preheating it as you go.
Trying to your hot area gets hotter further up. So they have a 3 tube design that actually splits the filament into 3 springs coming into the head. And then that heat is conducted up into those 3 areas. Those 3 zones are preheating plastic.
What is the mechanism to draw the floor film?
It pulls it all the way
So
out.
it pulls it, but then it has a big funnel that it just jams, it's close, and it pushes the
It swaps the filament, it completely rolls the filament back up, and then completely unrolls the filament, feeds it all the way back to the hot end again.
But
Like
it's
the
finishing
finishing
machine,
machine,
you're
you're
going
going
there.
Another one setting back. See,
It's just feeding and unfeeding just like we would.
It has a drive down there.
Yeah, like a regular.
And then it has 4 other drives
Up top.
One
And one
for
on the
each
back.
side. So this one backs out, I think, enough to clear the.
And then it's just click on that.
And then the other one, that one might throw, the other one
starts.
Yeah, and it actually has a cool little spring-loaded compensator that takes up slack between the 2 motor systems. And it's got switches, so it says, okay, you're done pushing it out, you can't push anymore. Now the other one takes over, and then it's got logic to know, not make the 2 motors right.
and the printer's right there. It's currently printing a color changing print. So after you're done, you pick it out how it works. Yeah.
But it's insanely slow.
Is there any way to,
Instead of having to have it do the color change, like on internal supports, like change before you need the color and then finish doing, say, the blue support with red where it's internal and not components.
Great, so internal info, I think there's actually is a way to purge the info, but the issue is, the color change in your info might not line up, right? So.
like, how white?
Yeah, or when there are more color change, there might not be that much info to do. And when there's quite a bit of info, there might not be changing any colors, so it's quite hard to get those to line up. But I suppose there's a way to do it. It might actually be a feature I just haven't yet.
He hasn't checked all the boxes.
Do you, I mean, do you have to purge, or can you kind of create home grade?
So another function is that it has a flushing volume. So here's how you set how much purge you're doing, right? So we have another chart. For example, if you're purging from white to black, it's only shooting out 187 cubic. I don't know how this is.
Millimeters, right? Yeah.
But if you're changing from black to white, from black to white, you're doing 667. So that's quite a bit more. Now you can change it does auto calculation of pulling through colors, and you can manually change add and multiply. So for example, if I don't want to purge anything, then probably with 0. Okay, so it's happening first with 0. It's just that would save you on material, but that wouldn't be much of a color.
Why does the different colors have no pigment involved, just mass?
Oh, there is. It's, yeah, it actually slicks to the outfit. The edges of the nozzle retain, the pigment a long time. So it takes a long time to get black out.
Pigment, it's not solid.
Yeah, so when you change filament colors, you have to actually, I would always push it through until that goes down. And they're always at the beginning.
But you can.
3 to 5 inches of.
I didn't realize that.
Yeah, and that's why some
But
filaments
it's
are
solid,
so
but it's clear, and like black wouldn't show other colors much, right? You can get away the shorter purge from a light color to a dark, from a dark to a light, kind of like pink, right? You know, it takes a little bit, and you go, white is so different. And you can see it on, any printer, right, where it's left in change filaments by hand. You can actually watch it coming out, and you can see it going, white to red goes white, pink to pink, right, and then you go to the reverse, and it's kind of surprising how much you have to send out before it goes from red to clear white.
This is just all part of Jerry's advertising campaign, just like the sell colors.
He's my promo code, man.
The first how you saw my
Yes. so-
Yeah, it does. It had a whole table of stuff. Yeah.
Because obviously, right, the larger the print, the smaller percentages.
Yeah, that's what it's showing. It's showing the
Little
range of
snowman.
colors.
The volume of purge is like way more.
That's what it's all really going to cost to pay. It tells you how much purge using, how much it takes, and how much racing.
And this can output, I mean, it just outputs, you could run on anything.
So that's interesting. The file that you actually export is also a 3ms file, and I suppose in that 3ms it contains a G code. So
Oh,
it's-
sorry, I mean, if you ran a single color print.
Yes, that would solve the HTML.
Oh, is it? Okay.
Yeah, so it's sending that 3ms to the cloud, and the printer's downloading it from the cloud. So you're not using the local network.
Oh, wow.
Well, so your network sit down, your network down.
Well, I have all sorts of magic that I'm doing now.
This is interesting, you've got 0 changeover, and you take an hour off your quick time.
Yeah.
Because I'm still waiting for that filament to come in and out on that.
Yeah, but it doesn't have to go to the food shoot.
Yeah, right.
That's it.
Matt just had a nice, instead of a purge tower, you just make another part, so you don't care about.
Yeah, that was what Jim was discussing the other day, was the like, why not print a craft part, but you can still print the surface.
So it's kind of like the concrete barrier with the concrete. Right? Like,
Yeah, yeah, that's-
I think that could down to.
Well, how much time would you save just printing it all in white and just coloring in the Sharpie or paint?
Get it down.
That's the Davy approach.
Got a couple of interns, right?
Yeah, actually.
So, once it's sliced, is your print local, or is your file local, or is it? You have to go to the cloud every time you want to print.
So there's an option, we have a print page that basically uploads everything and then print it downloads it. Another option is that we can slice to a file.
So you can, yeah, you can.
Yeah, we can export print size file or export all size file, so.
And that is 60.
It's kind of- yes.
I don't know your concert right on the dance.
Oh, yeah.
Yeah, exactly. It's one of the guys here shortly. Any other questions for Jerry? All right, thank you, Jerry.
Welcome.
Log into your computer so I can see.
I might have missed it when I stepped out, but, I can charge like.
Oh, yeah.
charge by final print time or mass rate or. Oh, no, it's actually free for now, because I'm using this for, real stuff. So when I was testing this printer and its AMS systems, I actually printed quite a few of these smaller NASA logos. I have 4 right now and the 9 more on the bill pick. So the 4, anybody who wants it, so free. And then the 9, you have to ask questions. They're done and come by and. Well, not anybody.
They're $38 a piece. No donate. Don't give me options, Jerry. Great. So I'm gonna talk a little bit about the thing over here. For those of you who are here, for those of you not, I've got pictures on the slideshow here. So about a month and a half ago, we bought a little fiber laser engraver. We have a 500 watt fiber laser, and I screwed around for about 3 months, finding out getting it set up. It runs, it works. What I wanted to do is set it up. It came with the Galvo head, which is the head over there off of the end of the machine. It's a pair of mirrors and 2 motors, and it steers the mirrors and guides the beam around. So there's no moving parts. It's just except for the mirrors themselves. And then it can mark or engrave things. And anyway, messed around with it for a while. Did a bunch of research, learned a lot about fiber lasers. We previously had some YAG, which are pulsed fiber lasers. They use flash tubes and a yttrium crystal to excite, make a laser. Yes. Fiber is literally fiber optics. It is a fiber optic conductive light source. So rather than our CO2 laser, where you've got a big glass tube and essentially a plasma in there and it's shooting out the end with about 80% reflection back and forth, 10 to 20% leaks out the end, you get your laser bounced off some mirrors and gets delivered through a lens. This goes through an optical fiber. It's very optically transparent at the same wavelengths that you can conduct the regular optical fibers or your glasses. It goes through polycarbonate, goes through acrylic, goes through glass, goes through sapphire quartz, those kinds of things. So it's optically transparent, which means it's really dangerous. Yet everyone on the internet treats these as though they're totally not dangerous. So this is probably the one that's never seen it. Anyway, long story short, I found out that our continuous wave fiber laser that we have is actually like the bee's knees of fiber lasers. If you want to cut things, it's the way to have them. However, if you want to mark or engrave things, it is not the laser source you want. So we had the Galvo head, we had the controller, we had all the parts, and we had a 500 watt fiber laser that we're going to run at 50 watts, so we didn't burn everything out. And it turns out you can't pulse the continuous wave laser. As the name implies, it wants to run continuously to cut things, not be pulsed on and off really fast. So long story short, I looked around to see if I could buy a switch mode or a Q source fiber laser, and they were $1,600. So I was like, okay, $1,600 it's a 50 watt laser. That sounds interesting. And then I looked around some more and found that I could buy one for like $2,000 with shipping to here, all assembled, ready to go. And I was like, why the hell would I build one when for a couple $100 more we can just buy the thing that we actually want? So we ordered it. It went on a boat, took a month or 2 weeks to get across to California, and then it got picked up at UPS. Took another like 14 days to get here. And it actually worked. There was a few holes and dents and things in the box. They chipped it very poorly. I was amazed that it survived just fine. Nothing fell out, which was good. And it actually works. It's going to need a little bit of adjustment. One of the aiming lasers is not aligned with where the actual laser comes out, but it doesn't really affect anything. It doesn't matter too much. So long story short, Jim did a fantastic job building an enclosure. You can go on AliExpress and you can buy laser safety glass, and that's what the green glass is. It's acrylic, but you can either spend $1,600 and buy a 4x8 sheet, or you can spend $1 and you can get a sample. So I asked them, can I just pay you to like cut me a bigger sample? Like I just need a bigger piece. They're like, no, $1 for a sample plus $5 shipping, or $1,600. I was like, I'm not spending $1,600. So I bought 4 cents worth of samples with a paint window, makes it a little cottage, and then the $5 stack. So it was like $20.04 to get 4 windows. Should have went with 9 just to harass Jim some more, but so that's routed PVC foam and then glued together. It's also sold as AZIC. It's like a PVC trim that you buy. A lot of people use it on houses and whatnot. So that whole upper enclosure is all glued together. And then the thing that's going to steal the show, of course, we can't have anything automated. So Jim made this very key sliding system. It actually, we had some cool pulley bearings upstairs. Got the nice wood flat. You can sand it. I don't think I've ever seen Jim with sandpaper in my life, but it feels nice and smooth. Long story short, anyway, so we got this enclosure. So this afternoon we played around with
Yeah, I got some shingles for my roof, where we put a little like there, and we finish this motif off a little bit.
Don't tempt him. So Sadiq's generative art, earlier when he was talking about that. So we etched this off a photo. The software that's running is Lightburn. And so Lightburn's the same as the CO2 laser. They have a Galvo laser controller. And then we played around with a bunch of other materials. So the one unique thing about a fiber laser is you control the frequency. So across the bottom there, that's 10 kilohertz to 100 kilohertz. That's the pulse train, essentially, that's running through it. And then it's 10% power up to 80% power. What I've learned from lasers in a long time of running them is that they'll tell you can run them at 100% power all day long, they'll work great, but in reality, you should do that. So we generally derate our lasers and they seem to run happily for a very long time. So we're probably not going to go above 80%, so there's no reason to, but it seems to work just fine. But what's interesting is you get super different effects. Like this is literally polishing the material up in the higher frequency range. The lower frequency range is getting really good absorption in the copper sheet. And then obviously as you change power, sometimes you get more burn through and more burned like darkness, and other times it doesn't really affect it as much. All these samples are sitting over on the table over there. You guys can check them out if you want to. This was playing around with whether you could make a circuit board by putting Kapton tape down on a piece of bare copper. And you actually can etch the Kapton tape. It's actually etched right here. It's 1 time less than it was right here, and it doesn't affect the Kapton. Like you can burn it with power and it won't absorb. But then we tried burning the copper, and the copper conducts through and burns the Kapton anyways. So you could probably play with it, get it to work. This is brass, same kind of thing. You get these effects where it's polishing versus building an oxide layer. So it's a weird thing that you get these different behaviors based on kind of what the frequency of the light is and the power. This is cutting through steel. This is also cutting through steel. The fun thing is after you're done cutting, you can use the laser to clean the surface. So as we saw here, down here, there's actually a whole row of cuts. And over here is a whole row of cuts where you're cleaning the surface away rather than burning the surface and marking it. So depending on what behavior and what wavelength and sort of frequency and what power you're using, you get cleaning or you get oxide building behaviors. So you can do some cool stuff. This was playing out with copper. It will cut through copper, aluminum, stainless steel, all the things that you can't cut with the other laser. Yep.
So you're saying you could go ahead, cut out the part, it oxidizes it, and then before you're done, go program it.
Run a cleaning pad, yeah, and essentially wash the surface off. So fun trivia. This laser will not engrave polycarbonate. This is polycarbonate. You can engrave polycarbonate. So the laser will go right through polycarb. Unless in this top layer, actually, Jim may have discovered a novel thing today. You put graphite on it, just a regular pencil. You can rub it with graphite, and the graphite will absorb, and it absorbs the heat and burns into the surface. This is a Sharpie, and then this was Sharpie on the bottom. So because you can go through the material, you don't have to etch the top. You can etch the bottom of this material. So this is kind of clever. You can go through stuff that's optically transparent to this laser. So you can do some interesting things. This was kind of a fun demonstration. These are the same laser wavelengths that are used to do tattoo removal. Again, they interact with pigments. They don't interact with skin necessarily. So if you have darker skin, more melanin, you'll get hurt. If you have light skin with less melanin, you will not get affected by this laser. We're not going to try that. That's how they do it. These are the same lasers that are used by jewelers for welding. So they do the flash tube pulse to get a better weld profile, because you can actually do multi-pulses really, really fast. And they use it to weld silver and gold and all sorts of stuff. So this layer here at 10% power is actually etching the dark pigment off. And it's sitting over there on the table. If you look closely at it though, it's actually leaving behind all of the blue dots of pigment. So the blue did not absorb enough energy to be ablated, but the black stuff did. So it burned away all the black ink, didn't touch it else. And then anything above 10% burns through the paper. So it is absorbing in a bad way. This is the same thing. The point here is this bottom layer. We're actually starting to ablate away the ink. It's hard to see on the screen, but this section here that I'm highlighting is lighter in color than the rest of the ink is. Of course, you can do dollar bill mutilation. So we accidentally cut through here, but this is knocking all the ink off. I don't know where my pennies went. There's a couple of pennies around. You can deoxidize the pennies. So you can clean up selective areas of the pennies if you want to. Have some fun, mustache, sunglasses, top hat, whatever you want to do. This is stainless steel. Same thing. I did some later on. I was putting some tabs on the text so you can make like a pop up. So I think that's all I got for pictures. What do you got? Questions?
Hey, Chris.
Yep.
On stainless with certain other frequency and power combinations, you can get some nice colors too.
Yeah, Jim ordered some titanium. So we're going to play around with some titanium to see if you get the same thing. I don't think it's a MAPA source. I didn't actually, I got to pop open the side of it and have a look at it.
Okay.
Those were more than our budget to play around.
And the new Hypnus is doing 3D engraving. You could bring a grayscale image into Lightburn, and the different levels represent how many passes at different areas. And as it vaporizes the metal, you end up with a 3D kind of thing. So people are doing coins, but some of them can take up to hours.
There's a STL processor that's on a Thunder Laser that we grabbed that does that. It makes a stacked series of images and attaches them. We're gonna use it. There's an entire, that shouldn't be surprising, an entire subreddit dedicated to laser cleaning. I gotta stop the share here and turn back on it here. I think the BNC and so probably my favorite thing is rust removal. You can actually burn the rust off of stuff. So there's a clamp over here. I'll pass it on, and a giant brick of steel. So there's a bunch of awkwardly heavy things over here, but this is probably my favorite thing. You can remove the rust from the surface of stuff. I was reading some academic papers on this, and it's removing like on the order of microns from the original base material. So it really is ablating the rust without touching the base material, because the reflectivity changes hugely. So the rust absorbs a ton of energy, but as soon as you get the white, clean metal, it starts reflecting. This is a dedicated rust remover. This is basically a galvo head. So it's got the same single mirror instead. And then it's a water cooled mirror. And so they're able to run higher wattages. So we took our 500 watt laser, continuous wave, onto a 1-axis mirror. And then, I don't know, accepted that you're going to lose your eyesight. You could run around with this thing and blast whatever you wanted. The galvo laser that we have, I think, has a 20-meter fiber. So this, it's just a 20-meter long yellow cord.
You can walk around with.
You can bring it anywhere you want it.
It sounds like a super villain.
They have handheld cutter heads for it, and so they use them for deconstruction and demolition. There's also SPT laser sells an obstacle remover. It is a thing about this big. It's either a CO2 or a fiber laser on the order of a couple hundred watts. And they use it to remove like Mylar balloons from power lines and bags and whatever you want. So, but it's conveniently called house together.
So is the red dot in here, that you're kind of.
So right now the laser's off. Let me screen share the other screen here. Yeah, this dot is not the laser. This is actually. Yeah, I would not leave this.
Is there a safety switch on the enclosure?
Yeah. Oh, so we do not have a safety switch in the enclosure.
So you only have to turn that off before the safety.
Alright. You control safety out of wood, nice. So I got the screen highlights in here. So I'm gonna close this down so you guys can watch this. Basically, looks like burn products.
Is the grading on this the laser right now? Like
The grading one. So this. And through the window, this looks like a barely flickering light. Out there, it looks like we're blasting the camera to death. But it's just running continuously, so if you want to walk it, check it out. There's a dust extractor, which isn't. It's a clean piece of metal. It's not good.
So, in the summer maybe, some laser showed up at the top. So
Yep.
I thought it was a Kickstarter.
Just you guys. Or that's the. Oh no, you're talking about the other. That was the UV laser.
Yeah.
Yeah.
And that was like a prototype for a Kickstarter or something.
That was somebody trying to sell UV lasers online, and they wanted people to.
Well, that's right. There was a handful of makerspace that they picked up.
Yeah.
And so that thing just sounds compared to this, or?
So that thing, I was hoping would be more effective. It does cut metal slightly better than CO2 lasers do, but it doesn't cut any. It doesn't do anything better than the CO2. So in our case, the CO2 laser is superior in all ways.
So we just have that like.
It's not cutting. Nope. It's adding oxide surface basically.
So, but it's right now, it's just going back over.
It's just gonna keep going over and over again, and nothing will change because it's already heated the material, whatever temperature it's gonna hit.
So normally you would stop this.
Yeah, normally it'd stop everything. The plate's gonna keep jumping back and forth. It's easy to pull and bounce. Yeah, the plate is.
It's. Okay. And on that plan, you have at least order it three.
So the fun thing is this is coated, like plastic coated, I guess plastic. So there's plastic, so it's gonna have a weird texture. It's actually helping the plastics. John, where you
Well, so with when you pick up the plan, you obviously did that in one pass, right? You weren't adjusting the height of things.
No, I wasn't touching the height of the laser. So the laser, the lens that's in there right now is a 70 millimeter work area. It's tiny.
Yep.
Intentionally to make the spot size really small, so you can mark really small things. We have another optic. This guy. These are about $60, and this one has a 10-inch work area, so you can do about a 10-inch by 10-inch area.
So because the laser doesn't move.
The laser doesn't. The head doesn't move. Nothing moves except for the mirrors inside that.
But I guess the question was like, if you had a multi-dimensional object with a response, how deep go?
The bigger, longer focus lens will have a bigger depth of field, and the tiny focus lens right now has like a 2 millimeter depth.
So that clamp is cool.
So the clamp on the big laser, the clamp I engraved on the larger lens. Yeah.
So if you did it on the smaller lens, a lot of that wouldn't have been hit, whether it be the top. or
Yeah,
the
you can watch it dry. It drops off super small.
Yeah.
So and actually, you can put a plate in there sideways to figure out your focal height. That's a common way to establish like where is my focal plane. Yeah. Just tip a plate on edge and then run a pattern and then look to see where the band is the best. That's Any other questions? So the fun thing with this, theoretically, that laser source is supposed to last very air quotes 100,000 hours. So if it's $2,000 and it lasts 100,000 hours, the operating cost is like nearly zero. The reality is, I'm gonna assume that thing runs for like maybe 2,000 or 3,000 hours before it dies. So, but even so, like at $1 an hour, you can, if you saw acid arc stuff, the thing's crazy speedy. So the cool thing with these fiber lasers is that the cost of these have just gone through the floor in the last 5-6 years. Even the 500 watt laser is like $10,000, and that sounds like a lot, but that is insanely cheap for what you get for it being a solid state, air cooled supply, nothing special. It's viable.
And the premise here is this was another tool that Sector.
That's gonna live in the machine shop, so I just drug it out here. And that dust collector is temporary. That's made by a company called Domino. Domino actually makes fiber marking lasers for food packaging. And I bought that at an auction a long time ago. So that when we went to trade shows or like did the first robotic stuff or whatever, we'd have an air filtration system suitable for a laser cutter. And so of course it's perfect for this. It's a half a charcoal and a bag filter on it. So to keep it dying, hopefully. Yep.
What do you think your exhaust will look like eventually?
It's gonna exhaust outside through a filtration system, just like the other laser does. So it'll go through the machine shop wall into a VFD driven floor, just like the other guy, and run through a filter stack. The good thing with this, it doesn't really generate a lot of like material. Like the CO2 laser is burning through stuff, and so it's generating all sorts of crap. This is not burning through much; it's burning through, micron level layers or buildings.
Well, so this
Depends on what you do with it.
Depends on what you're doing.
Well, this is intended for our usage for marking, not necessarily for cutting.
You can cut stuff, but it's not gonna cut through more than, I think there's a piece over there that's maybe a half millimeter thick.
Oh, okay.
So even that, your removal volume is tiny. The
We're
copper
not
is
gonna be
super small.
plowed through like that.
Yeah, no, not with this. So the interesting thing with this laser is it will cut through relatively thick things, but it re-welds itself because there's nothing to clear the channel.
Yeah.
You really need air assisted blast to slag out. Otherwise, it's called keyholing. So you punch the laser through. It establishes a molten pool, it inflates it, and then it vaporizes it, blows it out as plasma, so all the white light you're seeing. But then the adjacent molten pool flows in and fills. So if you keep melting and it just keeps flowing back, and you keep melting and flowing back, and keep melting and flowing back. Of course, the oxide is harder than the root material was. So you get aluminum, molten aluminum, flows in, oxidizes, and now it's got all this air and all this heat, and then now it's really hard to get out of there. So that's why the other laser has a head that does really close capacitive control for height detection, and then it's blowing like 90 psi compressed air out of it to blast the channel free.
You mean the big laser right there?
The 500 watt laser that will eventually set up has a copper head, and it uses capacitive standoff and stuff.
Oh, okay. And that'll be for actually cutting.
That's for actually cutting. Yeah, that's supposed to, again, air quotes, cut 6 millimeters deep.
Yeah. Okay.
So it seems that people get this cut thicker stuff by using like a wobble setting.
Yep.
That'll basically you're like ablating a channel around the line you want to cut instead. But of course, your curve goes up, your material removal volume goes up, and since this is not very fast at moving material, your cut times get like pretty stupid crazy.
Yeah, if you look at the table, we cut out all sorts of stuff. This is by far the thickest piece. But that's aluminum. It will cut through, but it ends up like perforated stuck. And I didn't spend a lot of time. That was just playing around last day. So I'm sure we get better at it. And I know for sure it is possible to cut through thicker stuff.
Yeah, but I mean, like you actually you basically ablate like a 1 or 2 millimeter wide cut trace.
That was-
I see people go.
Yeah, the thing I was playing with too is cranking the focus up and down to walk down as the material goes down, and that helps a lot. It seems to help clear.
Oh yeah.
So yeah, something to play with. The control card supports outside stepper motors and other things you can run on it. So I'm not sure whether you can get it to run. I know you can do a powered Z, but I don't know if you can get it to a powered Z while you're cutting. But you might be able to script it and basically cut and then have it move the Z down and cut and move the Z down. Anyway, any questions from anybody? So this is around if you want to play around with it. It has
Does it
applications
have a
for
color
ideas.
changing feature?
It doesn't. Actually, it doesn't. So as Jim was just talking about with steel and stainless steel, you can oxidize and get different colors. Jim was playing around too with putting graphite on stainless steel, and you can get actually a rainbow effect. Because you're building again an oxide layer. So anything you can do to chemically change the oxide layer build, you can do stuff. So take it away, Mr. Dennis.
So the frequency on the grid is not frequency of the light, it's how fast it's getting hit.
It's it's the frequency of the pulses.
This one's not mine. It's one I found on the internet, and I think it's 8 passes, even though it says 1 because they ran it multiple times. But it's showing some of the. This is considered a really good example. People strive for this many different colors to choose from. Other people search all over and find just a handful. So,
Does
you
it
know,
say fit for prep? Because that looks like it's been lie etched.
I think that's galvanized.
Is it? Okay, that might be too.
What's it like?
The color is the wavelength of light that's being absorbed or reflected based on the oxide coating you built on the surface lip.
You're building up different layers of
Yes.
This would be titanium dioxide or some titanium oxide. These are different thicknesses. Different thicknesses reflect different colors and create different wavelengths. And I think some different.
Dennis, have you had a chance to play around much with yours?
Titanium for titanium.
Only a little bit. I've done some slate coasters, and I did that guitar tag because you didn't have your laser working.
Yeah.
And I don't know where that is. I'll have to look for that. That turned out pretty well. He said I could mark the back of it for tests. So I did a little grid of different power and speeds and showed him like, well, we could do black if you want black, but we also found this really cool kind of bronze that matched the color that he was staining the guitar. And depending on what angle the incoming light was coming in at, it could get either darker or lighter than the material. So it was a cool optical effect.
So in other words, you've been slacking off. You've only done 2 things.
Yeah, it's that day job problem, right?
It's got to quit the day job. Don't worry about it. No big deal. All right. Anybody on Zoom got anything else they want to share? Otherwise, I'm gonna let you guys off.
So Dennis, you got a pretty big piece of stainless steel, don't you, in your driveway?
Hey, Dennis.
Actually, don't tempt me. I love that idea. That would be fun.
Dennis has a DeLorean, so the whole car is.
Is it blasphemous to put a Firebird on the DeLorean?
So I got a drone map thing that finished within like the last 2 minutes. So
Yeah, awesome. Go
so
for
I can show that briefly.
You do know Dennis is going to ding me on the audio though now because you're talking and the audio is great and my audio is bad.
Jensen's audio is fantastic, and yours was so bad at the beginning of the meeting. My wife made me put my headphones on instead of putting it through the speakers. So you've lost an attendee.
So this is a map of Owen Park. Took a scan when I was in Madison over the break period or vacation time, basically. So this is a series of 20 megapixel images. If I can remember, somewhere in here is like where the camera positions are. I don't know how to get to that, but loaded up some software that I hadn't messed with a whole lot, got it running yesterday, and you can zoom in really far, and it's like better quality than Google Maps. So a whole bunch of 20 megapixel photos, and it stitches them together. This one took about 3 hours, so pretty happy with how it turned out. If I go up near the parking lot area, I think it'll show, you kind of see the edges between it.
So all of the dead snowed areas this winter, and then the others, the hybrid view Google Maps. Right?
Yep. So there's kind of transition. You can see a little bit of the difference in pixel size. This map was taken at like 100 meters, so I could fly lower and get higher resolution if I wanted to. But pretty cool drone mapping stuff. It, I think, uses the GPS coordinates to figure out where it was on the world map and then stitches everything together.
Does OpenStreetMap support uploads yet?
I don't know if it uploads. I think you probably could upload it somehow. This is running locally on, well, it's using some sort of local thing through a browser to run this. I don't fully understand how it works. So it's web ODM running through Docker or something, because apparently that's the way to get to work on Windows. I don't know, I just installed it and followed the instructions on GitHub and Googled all the errors that I found and eventually got maps out of it.
And so, but we're looking at a Google map overlaid with your picture.
Yes, so this entire area is all Google Maps, and then like the park area right in the center is my map. I can.
Okay. And you just flew a drone around in like a circle and took a bunch of pictures, or was it a lot more
Pretty
complicated?
much. Well, kind of a grid pattern, but yeah, I just flew a drone over it, pointed the camera straight down, and took a bunch of pictures.
Did you align the images?
The software automatically does that.
Is it?
So you just upload like the 63 photos or 69 or however many it took into whatever the software is, and then it puts them together over the course of like 3 hours.
Is he doing some image processing? Like whenever you zoom in, figure out what image to show you at what time?
Well, it turns them all into like one big image file, I think. So the zooming isn't super complicated, but
Recursive files.
Are they doing any sort of like photogrammetry on that at all? Is there any sort of a?
Kinda. So if I click the surface model thing and it loads, it does 3D a little bit, but it's not like the other photogrammetry stuff that I've been doing. Yeah, maybe it's not actually going to show up properly. Sometimes it doesn't load right. Like it comes up with like a color code based on what it thinks the elevation is. It's like it's sort of doing a photogrammetric reconstruction, but mostly it's just stitching things together. It's like that's what it thinks the trees and buildings look like.
Yeah, but how many images? I mean, you only gave it 70
Yeah.
self pictures. I mean, that's pretty wild. It's got anything for that because that's cluttered.
Yeah, and the way that I took these photos was like not at all the way that I do the photogrammetry stuff. That's usually like you try and do an orbit around the object and get like as many different angles as possible, because otherwise you end up with.
I mean, photogrammetry. I mean, that's how they generate topological maps for the Earth. And
Yep.
I mean, it's very different when you're doing an object that has hard edges and stuff. But like for landscapes, I mean, you basically want all your photos pointed straight down. I mean, it's like super old school. So when I was working in Alaska, we were actually updating some of their maps from the really old school, and it was like literally they had sets of black and white photos that they had taken like on film from aircraft flying over, and then they generated maps by like literally aligning these things through a special device where you put two photos in and look through the lenses and find the overlay point to calculate your heights of different objects. Obviously, we were updating that, but like photogrammetry for landscapes, I mean, pointing straight down and just doing a flyover is basically exactly.
Yep. I think the overlap is probably the main difference between like how I do this and what would be better for photogrammetry. Because like if you're just doing orthophoto stuff, you can get away with like enough to line up the edges. For photogrammetry, you want the same points in at least several different images. I think for this software, the recommendation is like 80% overlap for photogrammetry and like 40 to 60 for orthophoto stuff.
Does your drone have orientation metadata and pictures it takes, or were you basically stopping and going straight down?
For flying the drone around, I was just guessing. I mean, it tells you GPS stuff, and there are like apps that you can use to fly it. There you can set up a grid pattern. It'll do like predefined overlap and stuff.
The other questions for anybody? It's pretty neat. You'll have to see if Jerry can photo color 3D print it for you. We need purple, blue, and like a pinkish, Jerry. What do you got? All right. Thanks, Jansen.
Cool.
All right. Anybody else in the meeting? All right. I'm gonna kill you guys off. Good to see everybody. Thanks for coming by.
Take care. Bye.
Yep, see you guys later.